Hello everyone, welcome to our pre-calculus lesson. This is lesson 22, finding the inverse of 2 into 2 and 3 into 3 matrix. These are the agenda. Inverse matrix definition, multiplying a matrix by its inverse, inverse matrix finding procedure, finding the inverse of 2 into 2 and 3 into 3 matrix, and in class practice and homeworks. So these are the things that we have in our mind. This is an example of maths that this matrix represent, and in our next class actually we will be working on this kind of application math. Okay, so that's why we kept it here. This is the definition of inverse matrix. If you have a matrix, let's say X is a matrix and you have another matrix Y. After you multiply X and Y, if you get the identity matrix in your answer, that means X and Y, they are inverse of each other. This is the definition. A matrix X and another matrix Y, if you multiply both of them, answer comes identity matrix. That means they are inverse of each other. And if you want to look at it from a very simple concept, suppose 5 is a number. What is the inverse of 5? Inverse of 5 means 5 inverse 1 or 1 by 5 or 1 by 5. So if you multiply 5 and 1 by 5, what is the answer? Answer is 1. 5 cancel out, the answer is 1. Okay, this is the identity matrix. As you know, in matrix, identity matrix actually act like 1 in matrix algebra, because if you multiply a matrix by its inverse, then actually if you multiply a matrix by an identity matrix, actually the original matrix do not change. So in matrix, identity matrix actually act like 1 in our algebra. Okay, some of the matrix sometimes they may not have inverse, which is called a singular matrix. If a matrix A has no inverse, then it is called a singular matrix. And other matrices, those who have the inverse, they are called non-singular. Some other matrices do not have inverse, and we will talk about it a bit in the coming slides. Why some of them do not have inverse. So how can you show that if this matrix and this matrix are inverse of each other? You multiply them. Okay. If you multiply them, after your multiplication, answer will come. We need to show that A into A inverse and A inverse into A equals to I2. I2 means 2 into 2 of identity matrix. If you multiply them, answer will come the identity matrix. In both order we have to multiply, then answer will come identity matrix. This is how we can show that. Suppose when you solve a math, from your solution, if you want to be sure if your solution is correct or not, then what can you do is you can just multiply your answer and the main question. That means this is the answer, this is the question. If you multiply them, answer should come the identity matrix. If you are working with 2 into 2 matrix, so answer will come 2 into 2 identity matrix. If you are working with 3 into 3 identity matrix, 3 into 3 matrix, then answer will come 3 into 3 identity matrix. Okay, so this way we can prove it, that which one is actual answer or not. This is the procedure for finding inverse of a matrix. First of all, to find the inverse of n into n non-singular matrix A, proceed as follows. Form a matrix A. This is the main matrix, and I of n, that means identity matrix, just in this form. Transform the matrix this into a reduced row echelon form. So we have to transform it to reduced row echelon form. The reduced row echelon form, this will contain the identity matrix In on the left side. So this side we have to make some identity matrix. On the left side of the vertical bar, the n by n matrix on the right side of the vertical bar is the inverse of it. So we have to make the left side identity matrix, and then the right side will represent the inverse matrix. We will show the example so that you understand it. This is the example given in the book, a little bit theoretical way. but just so that you all can see the inside engineering of this math. Suppose A equals to 3, 1, 2, 1. This is a matrix. And suppose that A inverse matrix is x, y, z, w. This is the inverse matrix. So according to our rule, if we multiply A and A inverse, our answer should be identity matrix. So that's why this into this equals to identity matrix. Then if we multiply it, if we multiply this whole thing this side, we get this. And then if we equate the corresponding term, this one, we will not solve math in this way. Do you understand? I'm just showing you just a inside story of all the maths. We can consider all this in the all maths. We can consider x, y, z, and then we can solve the math. But we will not solve the math this way. This is the theory why this math works. So if you multiply it, then we get this, and then if we equate the corresponding term, 3x plus z equals to 1, 3y plus w equals to 0, we can write it like this. Then from this equation again we can convert it to augmented matrix form. Augmented matrix form is 3 here, 1 here, 1 here, then this, and then the number. But you see this 3 1 2 1 3 1 2 1 is the same number, so we can actually make them into one form, which is this. Now we have this thing, and based on our rule says that we have to make this left side identity matrix, and we will do some operation. From the operation, we will try to make our left side as identity matrix, and right side, whatever comes, that will be the answer. So here you see this side became the identity matrix 1 0 0 1. So, and this side is the answer. Finally, since we considered it in terms of x, y, z, that's why we have to equate it and show all these things formally. But basically, this is the answer: 1 minus 1 minus 2 3. 1 minus 1 minus 2 3. This is the answer simply. Since we have considered that x, y, z for in our this line, in the inverse matrix, and in this form, that's why we just have equated them to show that x equals to what, y equals to what, z equals to what. That is the thing. But simply we can think that if we convert our left side as identity matrix, then our right side will be the inverse matrix. So let's try to do one math that we thought. Let's try to do one math. 2 into 2 matrix. Let's do one from 2 into 2. So this is a math 33 number math. So this is 6 5 2 1. So let's do, and this will be the another math from 3 into 3 matrix. So let's do first from here. 6 5 2 2. Sorry. Then we can write here identity matrix 1 0 0 1. This equals to. So let's start doing some operation so that we can have some answer. So first of all, let's do some rearranging. Put this row 2 in the row 1, just to, because they are 2 2, so we can actually divide it by 2 to get some answer, or this seems easier to solve. 0 1, then 6 5, then 1 0. It's not mandatory to rearrange it, but yep, this is one way to do it. That's it. Now what can we do is we can multiply this line by 3 and subtract it from here. We can multiply this line by 3 and subtract it from here. And before we do that, we can actually, if we want, we can divide this line by 2 to make it 1. Then we have to multiply it by 6. So which one we should do first? Both is fine. Both is fine. So okay, let's divide it by 2 first. Let's divide this line by 2. Then it becomes 1. It becomes 1. It becomes 0. It becomes 1 by 2. Now this line, so we said that this line into 3, let me write it what I'm doing here. So we have done R1 equals to R1 divided by 2. Then R2 equals to row 2 equals to row 2 minus 3 into row 1. 3 into row 1. So then 3 into row 1 means 2 into 3 means 6. 6 minus 6 equals to 0. So 0 here. Then this is 3 into 2 6. 5 minus 6 equals to minus 1. Then this is 1 minus 3 into 0 means 0. So 1 here. Then this is 0 minus 0 minus 0 minus this thing equals to 0 minus 3. 0 minus 3, so answer comes minus 3. Answer comes minus 3. So ultimately what we have here is, now see, in this line we have a negative sign, so we have to make it positive. So 1, 1, 0, 1. Not this line. This line. Oh, we have to make it 0 also. Okay. 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 Okay, so let's make it 0. Let's try to make that number 0. So we have to add these two lines, right? We have to add these two lines to make that number 0. So this is 1. This and this we will add. This is 1. And if we add this and this, answer becomes 0. Then 0 plus 1 equals to 1. Minus 3 plus half means half, then minus 3. So this is 1. 1 minus 6. 1 minus 6 means 5. So minus 5 by 2. So minus 5 divided by 2. And then this side is 0. And we are multiplying it by minus 1. So it becomes 1 minus 1 plus 3. So this is the solution of this math. Let's check if everything is good. Zero, half, 0, 1 minus 5 by 2 minus 1 3. Yeah, I just have checked it so that if there is any inadvertent or any careless mistakes anywhere in the calculation process. So yeah, this is the process, and here we have just in this line we have, what we have done is we can write it down here. This line R1 equals to R1. I think R1 plus R2. I think this is, and here this part is R2 equals to minus R2. We multiply it by a minus sign for this row 2. So our inverse of this matrix is 1 minus 1 minus 5 by 2 3. So this is the inverse of this matrix, and that's all. Actually, this will be fun to try it by keeping 6, 5, and 2 in the same place. I think that should also give us the pretty much same answer. Okay. Let's try to do this one. This is 3 into 3 matrix. We will follow the similar process. One, 0, 2, -1, 2, 3, 1, -1, 0. Then let's bring the identity matrix. 1, 0, 0. Then 0, 1, 0, 0, 0, 1. So this is 3 into 3 identity matrix. Now what can we do here is, let's keep the first line as it is. We have to do some change here later for this too, but uh, since we can see some easier form here, let's suppose this one and this one, if we add, then it becomes, we get a 0 here. So this one we can try first, I think. So we are adding row 2 and row 1 here, then we'll get 0, then 2 plus 0 means 2, then this is 5, this is 1, 1, 0. So what we have done here is row 2 equals to row 1 plus row 2. Then this one, so this one, for this one we can, this let's do with row 3 and row 1. So row 3 minus row 1, let's do R of 3 equals to row 3 minus row 1 to get a 0. We are trying to get a 0 here. Okay, we are trying to get a 0 here, 0 here, and ultimately in our left side, this side, we will make this. Okay, in our left side we will make our identity matrix. So that's the target. This is 0 here, then this is -1, -1, -1 minus 0 equals to -1, and 0 minus 2 equals to -2, equals to -2. Then 0 minus 1 means -1, 0, 1. So ultimately we have this here. Then what can we do is, between these two lines we can do some operation. We can multiply this line by 2 and add it with this line to get a 0 here. Yep, let's do it. So let's try to do it here. Let's try to do it here. There are some other methods also. What can we follow? What else we can follow? We can get a 0 here. So what we need is, we need a 0 here, 0 here, 0 here, and 1 here. So first let's try it. Or we can add these two line also. This one and this one we can add also. If we add these two line, then we will get 1 here, which we need. Okay, let's do that first. Let's do that first. So 1, 0, 2, then this is 0, this is +1, and then this is 5 minus 2, that means 3. The other way also possible, I think. 0, this. So what we have done here is, we are just adding this row 2 and row 3. Then it will become 0 here, 1 here, and 1 here. Okay, then this line, for this line In the next line, actually, we can directly add them. Let's write it as it is, because in the next line, I think we will see some direct answer will start coming here, I think. Because if we add this and this, then answer will get the shape that we need. So this is the thing. Then one, we still have this 2 here. We have to get rid of that 2. We have to get rid of that 2. Yeah. 0, 1, 3. Then if we add this two row, then it becomes 0 here. It becomes 0 here. Then it becomes 1 here. We are adding this to last line, so it is minus 1, 1, 2. The other things will remain the same. 0, 1, 1, 0, 0, 0, 1, 1. Okay, now we can, now the math will function a little bit faster. It will go to the solution a little bit faster. When you have in any line, when you have double zero, then actually math becomes easier to solve, because then you can do any operation. So you see, we need a 0 here. So if we multiply this line by 2 and then subtract it from this line, then we will get a 0 here. And all other number here is 0, so no problem with the multiplication. This is the benefit of getting 2 0 in a line. So 1, you see, we are multiplying this line by 2. Let me write it here. So this is row 1 equals to R1 minus 2 R3. Here also we have done row 1 and row 2 addition. So this is plus then, and this is 2 minus 2. 2 minus 2 means 0. This is 1 and this is 2. This will be minus 2. And we are subtracting. So this minus 2 will become plus 2. So ultimately plus 3. And this is 0. And this is minus 2. So ultimately it is minus 2. This is 0. And this is 2 into 2, 4. So minus 4. So let's write minus 4 here. All good. So this is 1, 1 minus 0, 1, 0, 0, 2 minus 2 equals to this, then 1, 1 minus, so it becomes plus, plus 2, 3, 0, 0 minus 2, 0 minus minus 4. Yeah, all good here. Then this line also we can do something to remove this 3, and we need a 0 here. So what can we do is we can multiply this last line by 3 and subtract it from the second line. That means our row 2 will be row 2 will be equals to row 2 will be equals to row 2 minus 3 into row 3 into row 3. This should give us the required thing, because this is 3, so 3 minus 3 equal to 0 we will get, and no problem with other numbers. So 0, 1 minus 1 equals to 1 minus 0 equals to this, 3 minus 0 equals to 0. We are multiplying the third row by 3 and then subtracting, so it is 0. Then 3 into 3 means 3, and minus minus plus, so it will become plus 3. Let's recheck. We are minus subtracting it, so minus minus plus. Then 3 into this means 3, and 1 minus 3 means minus 2. Okay, then 3 into 2 means 6. 1 minus 6 means minus 5. Okay, and the last line looks no problem. Last line is okay. So this is 0, 0, 1, and this is minus 1, 1, 2. So it looks like this is the solution, if we haven't made any careless mistake. in this kind of, in the inverse finding maths, the most problematic thing is, careless mistake. If we just miss anything, then actually it gives us a problem. So how do we know that if we have made any careless mistakes or not? We can make sure it by verification. So 3 minus 2 minus 4, let's verify it. Okay, then 3 minus 2, can I move it? Can I just move it from here to here? If I just can move it, then I will not have to write the whole thing once again. Yeah, I can move it. So let's remove everything. We'll try to verify it. Okay, we'll try to verify it. So we need some space. We will multiply these two lines now, this and this. We'll multiply it, and if after multiplication, if our answer comes identity matrix, since we are saying that this is the inverse, so after multiplication our answer should be inverse identity matrix, or else the answer is wrong. So if we multiply it, 1, we have to go this way and then come down this way. So 1 into 3 means 3, then plus 0, then this is 2, this is minus 1, so minus 2. It looks like first number is correct. Then we can do for the second line. So this is minus 2 plus 0, then plus 2. Then we have to go for this line, minus 4 plus 0, then 2 to 4, so plus 4. Then this line, this is minus 1, so minus 1, so it is minus 3 plus 3 to the 6, then 1 into so this is our second line, so we are doing this one. So minus 1 into 3, minus 1 into 3 means minus 3, then 2 into 3 means 6, this will be plus 6, then 3 into minus 1 means minus 3. Then this line, so minus 1 and 2, so it will become plus 2, then 2 into 4, so it will become minus 4, then this is 3 into 1, 3 into 1 means 3, so it is plus 3. Okay, then this line, now minus plus 4, then this is 5, so 2 into 5, 2 into minus 5 means minus 10, and 3 into 2 means 6, so it is 6. Then last one is minus 1, 3, so minus 1 into 3 means 3, minus 3 plus 0, so this line and this line is finished. Now this line and this line, so minus 2 plus 2, minus plus, and plus 0, we have this. So we have minus 4, this 1 into minus 4 means minus 4, then this minus 1, and this minus 5 means plus 5, then plus 0, because 0 into anything equals to 0. So regardless of what we have there, it should be 0. I think some of you already can see the answers. So 3 minus 2 means 1, this minus 2 plus 2 is 0, minus 4 plus 4 is 0, this is 6, minus 3 minus 6, so ultimately 0, minus 4 and 5, so ultimately 1, then 4, 6, minus 10, so ultimately it is 0, then 3 minus 3 equal to 0, minus 2 minus 2 equal to 0, minus 4 plus 5 equals to 1. Okay, so this way we can actually prove if our answer is correct or not. It is taking time. It always will take time. This will always take time. Okay, This is a time consuming process actually for 3 into 3 matrix inverse finding. Okay, this will take a bit extra time, but this is how we can actually find out the answer and the verification. There is another method actually. But that method is more time consuming. You know, there is another method for finding the inverse. So for 2 into 2 matrix, there is a direct shortcut method for finding the inverse, which is this formula. If your matrix is A, B, C, D, then actually you can use this formula to find out. First 1 divided by D, D means AD minus BC, then D minus B divided by so see what happens here is these two number interchanges the position, and these two number remains wherever it is, and just they take the negative sign. Here it is 1 divided by D. So discriminant, this is called the discriminant, D. This is determinant, not discriminant. Discriminant is B square minus 4AC from B square minus 4AC, that is determinant. So in the beginning we said that there are some matrices which do not have inverse. The reason is this determinant actually becomes 0. For some matrix, if this determinant is 0, then it is 1 divided by D. 1 divided by D, we have it actually in the formula, and for this 1 divided by D, we cannot find out the answer, because 1 divided by 0 is undefined. That's why. So this is the problem. That's why you cannot do it. So what happens in this formula? A and D, they gets position changed, and B and C, their position remains the same, but just only they takes a negative sign, and this is 1 divided by D. AD minus BC. So by using this formula, actually you can find out the answer for 2 into 2 matrix. Let's say suppose if I write here 2, 3, 1, let's say 1 here and 4 here, 2 into 2 matrix. When you have actually most of you, if you have practiced it by using this formula, because this is very easy to do the math. So 1 divided by AD minus BC means 2 into 4 means 8, and this is 3 into 1 means 3, so 8 minus this means 5. And then when you have it, you see our A and D will change the position, so 4 and 2 will interchange the position. This will become 4, and this will become 2, and this is minus 3 will come here, and then minus 1 will be here. So these two number will change the sign, and these two number will change the position, and that is the answer. You see, this method is so easy when you have a formula. Actually this is so easy, but unfortunately for 3 into 3 matrix you do not have a formula like this. Okay, there is no straightforward or very easy simple formula for 3 into 3 matrix. And of course if you go for 4 into 4 matrix, then it will become like wildly crazy, you know. There's the problem with this formula. That's why we discussed the math by using our identity matrix multiplication and other things, that process, like this process, because this process works for all the matrix, 2 into 2, 3 into 3, 4 into 4, all the matrix. That process works for everywhere. Alright, so try to practice some maths like these maths, 31, 32, 35, 36, 38, and 39. We have all this math here actually in this slide. So try to practice some maths from here, and we can solve a few more during the class, or we can introduce something new also if everything is fine. Let's see. So thank you all, thank you very much, and have a good time. See you all in the class. Bye bye.